Hello, everyone, and thank you so much for the invitation to speak at the seminar. It's really exciting to be up here to get to share my research with you. So I come from the background of kind of healthy adolescent and childhood brain development, and I'm particularly interested in reading. So I want to start out this talk by getting you all as excited about reading as I am. It might not seem like it on the outside, but I promise inside I am very excited. So reading it's a ubiquitous skill. It's something that we do every day, right? And it's easy to connect it to things like how well you do in school or learning new information, reading a textbook and things like that. But I think it's also important to realize that reading is a very social ability as well, especially from my perspective as kind of like an adolescent brain development kind of person. Since we all have devices like laptops and phones, and we're using them to interact with people on social media on like a minute-by-minute basis these days, I think that reading can also be seen through the lens of mental health and wellness and kind of how you interact with your peers and maintain a social identity. So I think it's a fairly wide-reaching skill. It can impact our lives in a lot of different ways. Now, there's a really nice talk at last year's OHBM that I want to harken back to that showed that the areas of the brain that are involved in reading belong to many different functional networks. So we can see in this figure that there's some visual and motor areas that are active during reading processing, but there's also a heavy weighting towards attention and executive function and things like that. And I would argue that's because reading is such a multifaceted skill. There's many different cognitive components of reading that need to work together in order for the skill to be successfully produced. And of course, this involves a lot of kind of higher order integrative networks to kind of pull all of that together and do things like recall the meaning of words and maintain a narrative and keep track of syntax and all that fun stuff. And the regions of the brain that are involved in reading change over time as well. There's kind of like an earlier processing method that people like kids use or earlier readers, where they're typically sounding out words and recalling the meaning of the word based on the spoken language equivalent. Whereas adults or more skilled readers tend to just recognize the shape of the word and more rapidly recall the meaning of the word that way. And this involves kind of a shift away from the classic language regions like Wernicke's area towards ventral, occipital, and temporal white matter. Now, DTI, the great DTI, has already been used to build a wide foundation of our understanding of how white matter supports reading, which is great. Typically, we see that tracts that are connecting those regions of the brain that are involved in reading support white matter in some way or another. There's some nuance there because we don't always see every tract related to reading in every age range that a study is looking at, likely because those regions are changing as the reading network is refining. And the trends of these studies are typically that, we have FA and MD from DTI, and we have developmental trends of those measures that are very well understood. FA goes up, MD goes down, and if tracts follow those trajectories, they're related to increases in reading ability, so fairly developmentally normal. But the issue with our DTI measures is, on the next slide, perfect, that FA and MD kind of average across very important microstructural factors or features of white matter. So things like how much myelin tracts have, how densely packed axons are in the tract, and the coherence of those tracts directing traffic essentially from one region to another are all averaged in FA and MD. But there are some new techniques that can give us more specific measures of white matter microstructure, like NODI and IHMT that I'm using in my study. So from NODI, we can get the neurite density index and orientation dispersion index, which are measures of axon density and fiber coherence, respectively. Whereas quantitative IHMT from the IHMT technique is our nice measure of myelin. So I'm applying these measures alongside DTI to answer the research question of how white matter microstructural factors are driving links between white matter and reading. To do so, I'm collecting data from an adolescent population of 7 to 13-year-olds at their first visit. We've got 27 so far that have come in for one scan, and then returned 2 years later for another MRI scan and another cognitive assessment where we're looking at reading skills. I'd also like to note that we're looking at individual components of reading rather than reading as a whole, just to get at those more specific relationships between white matter and reading. So we're looking at phonological processing, which is kind of a really strong predictor of reading ability at any age. It's used a lot in the literature. And then we have speeded naming, which is getting a kind of like rapid information processing. It is really important reading for kind of accessing the meaning of words and bringing them to the forefront of your, executive function working memory. And in typical DTI analysis fashion, we get this beautiful nest of fibers in the brain. And so for us, we segmented out some reading-related white matter tracts that are fairly common from previous literature, and we looked at the mean microstructural measures in all of these tracts at the 2 time points and calculated a change score of time 2 minus time 1. And we were doing partial correlations just to investigate those initial relationships in each tract, looking at change in our microstructure measures and how they relate to change in our reading scores in our kids. And so here are our results. There's a lot to kind of dig into, but I'm going to spend the rest of the presentation kind of walking us all through it. So I'll start off with the general trends, the kind of broad notes from these graphs. First off, we see a lot of relationships that are kind of widespread throughout many different tracts between white matter microstructure and components of reading. The correlations that we see here are all fairly high magnitude of about 0.5 for all of these relationships, so fairly large effect sizes, which is nice to see. And another thing that I want to note here is that while we did look at change in FA, there's no relationships here between FA and any of our components of reading, which is kind of not what I expected. But it's kind of nice to be able to use some more specific measures of white matter microstructure rather than the general average of white matter integrity that FA gives us, because we can still see that there are relationships between white matter reading in our kind of early adolescence age range. Oh, and I should also mention that these are partial correlations controlling for age and gender. So kind of zooming into the more specific findings, first I'll focus on our myelin measure, quantitative IHMT, which showed us 4 relationships between myelin and phonological processing, which is fairly expected, especially in these tracts. There's the corpus callosum body and splenium, and the left hemisphere inferior longitudinal and frontal occipital fasciculi. So these tracts are kind of involved in the more skilled reading processing that I was mentioning earlier, having to do with that kind of ventral, temporal, occipital connections and recognizing the shapes of words and recalling the meanings that way. And I think it's also interesting to note that these tracts all had fairly similar relationships. So increases in myelin over that 2-year period as these tracts are refining to support reading all produce kind of a similar increase in reading ability. As for our NODI measures, the neurite density index, we saw increases in 2 tracts, the corpus callosum body again, and the right hemisphere inferior frontal occipital fasciculus. This was fairly interesting because it's not the same tracts that we saw changes in myelin in as supporting reading, and it's even a right hemisphere tract, while we know that language and reading are fairly left lateralized. So this is showing us that there's still some right hemisphere involvement in reading ability. It makes sense because the left eye is processed over there. And also it shows us that axonal packing is important for reading, but in different tracts and possibly to a lesser extent than myelin. In terms of orientation dispersion, we saw 1 relationship in the left uncinate fasciculus, and the negative trend that we see here is what we would expect, because lower orientation dispersion is indicative of higher fiber coherence. So higher fiber coherence in the left uncinate fasciculus was also related to improvements in phonological processing, which is great to see. And the uncinate is another kind of classic reading tract, so that's not a particular surprise to us either, but it's nice to kind of confirm that there's some things going on there in adolescence. And finally, our speeded naming results for our other phonological measure. We saw relationships in the corpus callosum with NDI in the body and splenium. Again, increases in NDI related to increases in speeded naming. This isn't a particular surprise because we have the corpus callosum popping up in a few different areas here, and I think that kind of shows that this is obviously a very major tract that's connected to hemispheres and could be involved in general cognitive processing in a lot of different ways. So it makes sense that this tract would be supporting kind of rapid information processing and more general cognitive ability. So in terms of our takeaways from this presentation, I'd like to note there are techniques available that we can use to build upon our DTI-based understanding of links between white matter and cognition, in my case, reading. In this investigation, I've shown that maturation of ventral and callosal white matter during adolescence is linked to improvements in reading skill, very important reading components that I've shown here, phonological processing and speeded naming. And finally, that the features of white matter microstructure that are related to reading vary depending on the tract that you're looking at, likely because of the interplay between which regions are involved in reading processing at any given time, and also which cognitive components those tracts are actually involved in conducting in the reading network. And with that, I'd like to thank all of my wonderful lab mates and my collaborators and funding sources, and thank you so much for your attention.